We're going to be going over sine law and cosine law. Okay? Sine law, there's 3 different times we'll use it in a triangle. So when we were introduced to this, we did sine law with non-right angle triangles and cosine law with the same. But it doesn't mean we can't use them. It's just that these tend to be more complex formulas, as you guys see over here, than just using these 3. We're going to go ahead and use sine law and cosine law to solve some right angle triangles just so you can see that they work and the reason we tend to use the other ones behind it. So sine law, we normally use sine law if we have side, angle, and angle, angle, side. If you look at this, right now what we have is an angle, and a side. Okay? So we're going to be using cosine law to solve this. In this question, they want us to solve...
Yeah, you mean sine, yeah.
What did I say?
Cosine.
Whoops, sorry, sine law. Thank you. They want us to solve this side as x. Okay? So we're going to set up our sine law. So we have our sine law here. And we're going to name the triangle. We'll call it A, which makes this side A. Angle B makes this side B. And angle C makes this side C. So we're going to go about filling this all in. Sine. Our angle A is technically unknown right now. Now we could solve it easily. Anyone know where it would be?
90 plus 75 minus 1.
Which is?
I have no idea.
15.
15, man.
15!
The way you can think of that, especially with right angle triangles, is 90 degrees minus 180. It's going to be what? 90. Right? That takes away half of the triangle. So really it just becomes a question of 90 subtract 75.
15.
Very good. We already got that. Okay. So we have sine 15 over side A. Sine B, which is 75. Over x is what we're trying to find. I'm just going to move this over. Okay, and then finally, we have sine 90 degrees divided by 16. Now, in order to solve sine law, we need a ratio that's complete. Correct? The only ratio that actually is complete here is the one with our sine 90. We have the opposite angle and the opposite side. So we're not going to be using this fraction in the ratio here. And since we're solving for x, we're going to set it up with just these 2 fractions equal to each other. So we go and rewrite this. Sine 75 divided by x is equal to sine 90 over 16. Okay? It's a little slow today. So we don't want to be working with our fractions, so what's the easiest way to move both things to the other side? We're going to cross multiply. When we cross multiply, we're going to have 16 multiplied by sine 75, which is equal to x multiplied by sine 90. Okay? And again, our goal here is to get x by itself. But what I'm going to do is I'm actually going to equate the sine 75 and sine 90. So 75 sine gives us 0.9659. And on the other side, 90 sine gives us the number 1. So essentially, this number 1 is not important to us. 1 times x is just going to be x. Okay? So x is equal to 16 times that. 16 times 0.9659. What did you say? 15? 15.45. Okay. 15.45 meters. I think that's what it's being measured in. But I want you guys to bring attention to this here. Had I set this up strictly as ratios, we would have had, we were looking for this side, and we would have the opposite and the hypotenuse. So we would have been using sine 75 is equal to opposite, which is our x, over the hypotenuse, which is 16. So that's very important there because I want you guys to see
You do that with right angle triangle, right?
over here. Oh, I jumped a step here. If I had just brought x over in this step, so we'll write it in blue, I would have actually been left with sine 75 is equal to x over 16. And my sine 90 would have became what number? Do you know? What's sine 90? 1. So, if you guys noticed here, even though we did it with sine law, the sine 90 would just be the equivalent of 1.
Yeah.
So these two things here end up being the exact same thing. It's just when we set up sine law, there's a bit more work involved with it. We could have jumped right to one of the ratios. Now, if you don't feel like you'll remember the ratios, you can always use sine law to do this. But like I said, there's more work in doing sine law than just solving it with one of the 3 ratios. Okay, here's another example with cosine law. Or, sorry, I've kind of given it away. But let's say we're solving for this side of a triangle, and it's a right angle triangle. Maybe I don't know the other formulas. The only formula I know is cosine law. And what we have here is a side, angle, and side. Well, I know that I'll be using cosine law in this instance. Okay? So I'm going to bring this law over. We're going to name our triangle. Now, recall, I'm going to call the side I'm looking for C. So because this is C, this makes this angle C. This can be A, angle A, and sorry, B, angle B. I wrote that A wrong. It should be lowercase. Okay. So here's our side A. It's not 4A. We're going to plug this information in. We're looking for x. X is our C squared is equal to A squared, which is 4 squared, plus B squared, which is 3 squared, minus 2. A is 4, B is 3, cos
C.
Cos what?
Oh, 90.
90. Now, I'm going to draw your attention to this. Okay? Normally what you guys do is you end up... What you guys end up doing is you guys tend to multiply this, and then you know that we have to multiply by cos 90. Okay? So I'll go about doing that. I'll humor you for a moment. We have x squared is equal to... This will become what? Or let's actually just leave it like this for now so that we can draw similarities. 4 times 2... sorry, well, negative 8 times 3.
Negative 24.
Negative 24.
1.
Times cos 90. Okay, so cos 90. 90 cos is
0.
0.
So that makes sense.
So this becomes x squared is equal to 4 squared plus 3 squared minus 24 times 0, which is going to give us what?
0.
0. Okay, so essentially we're going to be left with x squared is equal to 4 squared plus 3 squared. And right here is where I want to draw a relationship to something. You could just use Pythagorean Theorem to have solved this. We didn't actually need the cosine law, okay, in order to solve this question. We could have just used Pythagorean's, and if you notice, that's exactly what we ended up getting. The 2ab cos c ends up dropping off because cos 90 is 0, and 0 multiplied by anything is 0. So in the end, anyone know what the answer ends up being?
25.
25 square root of?
Like 12, 11 something. 10.
11 times 11.
All right, let's do it all up for you.
25.
16 plus 9 is 25.
What's like the sum
Oh, what?
5.
Isn't it 5?
Oh yeah, 5. Alright, 5.